Hello and welcome to this video where we are going to be talking about the stack and the heap in Java. So let's get started. So where does everything live, such as objects, primitive types, such as int, byte, all that good stuff, and where the instance variable lives? Well, before we can create an object, it makes sense to understand where these objects live and how long they live for. There's two areas of memory that we will be caring about when it comes to Java. One where objects live, which is the heap, and one where methods and local variables live, which is the stack. So what happens when a JVM, a Java virtual machine, starts up? Well, when a JVM starts up, it gets a chunk of memory from the operating system, and we allocate a piece of memory for our particular Java program. How much memory do we get? Well, it all depends on the JVM and which platform we're using, which operating system. Usually we don't have to care about how much memory it gets, but if we're using, if we're going to be creating a huge production-based product, it's probably good to check out how much memory we're going to be using. Try to get a rough estimate. We can change the size of the heap or our stack for that matter. But right now, let's not worry about that. All objects on the heap are garbage collectible. So this is an example of the stack and this is an example of the heap. Firstly, with a stack, method, invocations and local variables live here. So local variables, we'll get onto those in a minute, such as instance variables, local variables, object variables, which I shall be going over shortly, but mostly you can see here we've got the three methods on the stack, and on the heap we have three objects. Again, all these objects are live objects and these are collectible by the garbage collector. So if we have a object-based variable where we declare an object in a variable, that will actually live on the stack, but it will be a reference to the heap for that particular object. Here we have instance variables. Instance variables are declared inside a class. So here we have car, and then we just have int wheels. These are, as it says here, defined or declared inside a class, but not inside a method. They represent each individual field that an object has. So our object could be a car. We could initialize a new object called car, and then we have this instance variable, which is our wheels. Every car has wheels, so every car will have an instance variable in this case. Local variables. Local variables are declared inside a method. So here we have foo, int, that's our parameter. At this particular case, that is also a local variable. They're temporary variables, so therefore they only live as long as the method is on the stack. The method being on the stack, that is with the curly braces. When it comes to an end of the curly braces, it's no longer on the stack. Jump down to methods are stacked call methods. So here on the side where we have go and do stuff, and we have six. These are just variables and parameters even, or sorry, not parameters, local variables. So this holds two methods, this call stack. We have go, do stuff. And then for go and do stuff, again, we have those local variables. So when we call a method, the method lands on top of the stack. The stack frame holds the state of the method, including which line of code is executing and the variables for that particular method. The method on top of the stack is the method that is currently executing. So when we're working with a stack, you can check the Oracle documentation for this. We're working with a last in, first out. So that method that is currently executing on top of the stack is the method that is currently going to come off first. So if we have let's jump down, I'll show you an example. So if we have an example of stack here, we have do stuff, go, and insane. Firstly, we call do stuff. So do stuff goes onto the stack. Then as you can see inside do stuff, it calls go. So then go goes on top of the stack. And the reason do stuff is still on the stack is because it's not finished. Whereas go is something we're calling inside do stuff. So we cannot leave do stuff obviously until go's finished. So do stuff is now at the bottom of the stack, go's on top of the stack, and inside go we call insane. So insane goes on top of the stack, and all these like xis, all these like arguments are just local variables for these particular methods. But as you can see, do stuff gets called, then do stuff calls go, and then go goes on top of the stack, Inside Go, we call insane, so that goes on top of the stack. Once insane's done, that gets popped off the stack. Then we go back into Go, finish off the curly braces, that gets popped off of the stack. And eventually we come back down to Go, which is the last of these four columns. And then Go, and you see insane is no longer on top of Go. So then once Go's done, it'll go down to do stuff, and then the stack's empty. So yeah, that's pretty much how a stack works. Local variables that store objects. Firstly, let's remember that variables are nothing but reserved memory allocations. So these memory allocations are just put together as soon as we, assign a variable. We keep a little bit of memory inside our assignment just to make sure it's ready for when we need that. So this means when you create a variable, you're reserving a space in memory based on the data type of a variable. The operating system and all the other things that come with it, the JVM, what particular version you're using, decides what can be stored in that reserved memory allocation. So therefore, by assigning different types to different variables, you're storing integers, decimals, or characters in these variables. We store it based on that size. The two types of data types in Java, reference and object data types. So let's go down to referencing an object. A non-primitive variable holds a reference to an object. So here we have a method called Go. It has a local variable called D inside. As you can see on the stack we have Go, it's pointing as a reference towards the object. But this particular object, obviously it's living on the heap right now. The reference to the object is stored on the stack, but as you can see what we have here, we have Go with D. So as you can see in here, there's really no need for this to be here. The reason for this is because if we have local variables inside an object, the variables itself do not live on the stack. So we could have, the reason I did this is because D, we could call D, the type which lives on the stack but points towards the object. But let's say, for example, we have a local variable inside Go, which is D. It doesn't live on the stack, it lives inside the heap with the object. So just remember this method here, let's not call it a method, let's just call it, say, a primitive, not primitive type, let's call it an object reference. So we could just call it car. And from here on out, this car object reference, you could kind of see it as a variable which is on the stack, but it's pointing as a reference towards the object, which is how objects are stored. They're stored on the heap. The reference to that object is stored on the stack. That's something you always have to remember. So what about instance variables? As I just mentioned, we have an object on the heap that holds a bunch of instance variables, but where do they live? Well, they live inside the object. They belong to on the heap, and the compiler knows this. So creating objects, how do we create an object? Well, it's very simple. We can make a reference to a variable of a class. So here we have car, which is a class, and we're calling it my car. Then we're doing an object assignment to the reference using the equals. So we're saying new car, and it kind of looks like a method, but it isn't. What we're actually calling is the car constructor. The constructor is something that runs first when you initialize an object. So in this initialization of that particular object, the constructor will automatically be created and it'll be empty, but you can create your own by just naming it, say, public car, and then that'll run first. And you can see it's not a method because it has no type, like return type, in between that particular statement, which I'll show you in a second. So I didn't write any constructor. As you see here, we have public car. We generally write a constructor the same name as a class, which you have to do pretty much, or the compiler will throw an error. If we don't write a constructor, the compiler would create a default one as mentioned, and there's no return type, as you can see. That's because it's a constructor, and if it was a method, we put the return type between public and car. And constructors can be overloaded, so you can have many constructors. The heap, more important things. So when a Java program starts, the Java virtual machine gets some memory from the operating system. Java virtual machine, or JVM, uses memory for all its needs, and the part of memory is called Java heap memory. Whenever we create an object using the operator, the assignment operator, memory is stored and allocated from the heap, and when an object dies or it's being garbage collected, memory goes back onto the heap, which is space in Java. This is very important. As you know at the start, I was talking about good practice for big products, big product projects. So we can set a minimum minus XMS and maximum XMX value. And we can also see the size of the heap using these JVM options. The heap size does not determine the amount of memory your processor uses, so if we're into multi-threading, we may have to look at that just to see our size of our heap and what processes are running inside that. So for efficient garbage collection, the XMN value should be lower than the XMX value. Heap size is not determined by the amount of memory process needs, as it says here. So yeah, remember that and potentially take a screenshot and note that down. That's really useful if you're running big production projects. So let's talk about memory part 1. If there's no memory left on a stack for storing function calls or local variables, the JVM will throw a Stack Overflow error. And you may have been on the website Stack Overflow, that's where it got its name from. So while there is no more heap space for creating an object, the JVM will throw out of memory error, which is a Java heap space error. It's not as well named as the Stack Overflow error, but nevertheless. So the garbage collection aims to collect unreachable objects in the heap, which is very useful. We're going to have a video on the garbage collection, I believe, after this or within the next 5 videos. Everything that's reachable from every stack of every thread will be considered as a live object. So I don't think we'll be collecting those, while the garbage collector will not. There's also some other root set references like thread objects and class objects, which we'll look into a bit later. And part 2 of this, let's talk about memory. If you're running a recursive function or method in this case, where it's calling itself, you can quickly fill up the stack memory. So be sure to watch out that we don't, get a Stack Overflow error, because another difference between the stack and the heap is that the size of the stack memory is a lot lesser than the size of the heap memory in Java, which kind of makes sense because you're storing like primitive types on the stack, whereas we're storing objects which could have a fair amount of data on the heap. So variables stored in stacks are only visible to the owner thread, while objects created in the heap are visible to all threads, which is very useful. In other words, stack memory is kind of private memory of Java threads, while heap memory is sharing among all threads. And that we'll jump into multi-threading later on in this course, but it's something you will need if you ever want to become, if you ever want to get to a point where, as a production programmer, you will need to know multi-threading. Most important thing to remember for this particular stack and heap video, I would say that we only care about 2 types of memory, the stack and the heap. That's in Java. Instance variables are declared inside a class. Local variables are declared inside a method or a parameter. Object reference variables also stored on the stack, but just with a pointing reference to the heap. All local variables live on the stack. Object reference variables live on the stack as mentioned, but as a reference to that particular object. That is very important, try and remember that. All objects live on the heap. So yeah, that's kind of it. Let me know what you thought of this video. I really hope it was helpful. Once you get a good understanding of the stack and the heap, you can kind of mess around. You can create like cool stuff. You can actually create a stack yourself in Java, which is pretty neat, and potentially I'll show you how to do that in the future. But right now I just want to lay the foundation for Java, and I'm going to start moving things over to my website, which is cognitivesurge.com, building that at the minute, and on there we'll have some interesting projects that we'll be creating. Yeah, remember to subscribe for more videos. I'd love to hear all your feedback, so please leave a comment, and don't feel bad about asking any sort of question. There are no dumb questions. You can either leave it in the video or you can tweet me, so it's a bit more private that way. So feel free to ask me questions. Remember to subscribe for more videos and let me know what you thought of this video. And if you have Twitter, follow me on Twitter @CarlHodwin. Once again, thanks for watching and have a good day.